Time travel, is it actually possible? The full truth. What if I told you that right now, at this exact second, there's a version of time travel happening, and it's not science fiction. It's physics. It's math, and already been proven. Astronauts on the International Space Station are, quite literally, time travelers. Every single day they spend in orbit, they age a tiny fraction of a second slower than everyone on Earth. By the time cosmonaut Gennady Padalka returned from his final mission, he had traveled about 1/44th of a second into his own future, permanently. Sounds small. But it proves something enormous. Time is not fixed. It bends, it stretches. It slows down and speeds up depending on how fast you move and how strong gravity pulls on you. So the real question isn't, is time travel possible? We already know it is, into the future at least. The real question is, how far can we push it? Could we build a machine that sends a human decades into the future? And the one question that keeps scientists up at night, can we ever go backward? Stick with me for the next 20 minutes, because we're going to break down the real science, the wildest theories, and the terrifying paradoxes of time travel. No fiction, no fantasy. Just what physics actually allows. Before we talk about traveling through time, we need to understand what time actually is, and this is where most people get it wrong. For most of human history, we treated time like a steady drumbeat. 1 second here on Earth is 1 second everywhere in the universe. Isaac Newton believed this. It felt obvious. It felt true. Then, in 1905, a 26-year-old patent clerk in Switzerland completely destroyed that idea. Albert Einstein proposed something radical in his special theory of relativity. Time is not universal. It is relative. It depends on how fast you're moving and how strong the gravity around you is. Time and space aren't separate things, they're woven together into a single fabric called spacetime. Here's the wild part: the faster you move through space, the slower you move through time. This isn't a philosophical idea, it's measurable. It's been tested with atomic clocks flown on airplanes, satellites, and even in laboratories using particles moving near the speed of light. Then in 1915, Einstein went even further with his general theory of relativity. He showed that gravity also warps time. The stronger the gravity, the slower time moves. That's why GPS satellites, which sit far from Earth's gravity, actually run faster than clocks on the ground. If engineers didn't correct for this every single day, your GPS would be off by several kilometers within hours. So here's your first big takeaway. Time is not a river flowing at the same speed for everyone. It is flexible. It stretches near massive objects and near incredible speeds. And that flexibility is the entire foundation of everything we're about to explore. Let's start with the direction of time travel that is not just theoretical, it's already been done. Forward time travel. There are two ways to do it: speed and gravity. Method 1, velocity time dilation. The closer you get to the speed of light, the slower time passes for you relative to everyone else. This is called time dilation, and it comes directly from Einstein's equations. Imagine twins, one stays on Earth. The other boards a spacecraft that travels at 90% the speed of light to a nearby star and back. When the traveling twin returns, decades might have passed on Earth, but for them, only a few years went by. They've aged less. They've physically traveled into Earth's future. This isn't a thought experiment anymore. It's called the twin paradox, and its underlying physics has been confirmed repeatedly using particle accelerators, where unstable particles moving near light speed decay slower than expected, exactly matching Einstein's predictions. Method 2, gravitational time dilation. The second way involves gravity. The stronger the gravitational field, the slower time passes. This means that if you stood near the edge of a black hole, technically near its event horizon without crossing it, time for you would crawl compared to someone far away. This isn't fiction.